An LED are light-emitting diodes, but how do they work? A diode is an electrical component that only allows the current to move in one direction from the positive leg to the negative leg. In the LED, it is made of small components that are specifically made to make the LED light up. Those components are insulators that don't allow for energy to flow through, semiconductors that allow for only a small amount of energy to flow through, and then conductors that allow for a free form of electrons. In the LED, there are two types of semiconductors that make up what we call a p-n junction. The N-type uses an action called phosphorus doping that adds electrons into a neighborhood of silicon electrons, making the atom more negative. Whereas the P-type uses an action called boron doping that is used to make the flow of electrons flow more throughout the current because of the hole that is created from the boron element. As the current is flowing through the semiconductor materials from the positive side to the negative side, with the electrons acting with holes that are constantly being produced, they start to create a flow of energy moving from one side to another. After the process of doping happens, the electrons are in the valence band. That is simply the outermost electron orbital of an atom of any specific material that electrons actually occupy. This is closely related to the idea of valence electron. Once the electrons get excited in the valence band, they jump into the conduction band. The conduction band helps the electrons to flow freely to help create a current. In between those bands is what is known as the band gap. That helps the electron produce energy to move into said band. Overall, as the electrons are reacting with each other and is moving around, it produces what we call light.
After talking about how LEDs work, let's talk about the difference between red and blue LEDs. The difference internally between red and blue LEDs is that red LEDs need less voltage than blue ones. This is because red light has lower energy photons. In addition, red photons of light carry about 1.8 electron volts of energy, while each blue photon transmits about 3.1 electron volts. The difference in band gaps between red and blue LEDs is the size. An even smaller band gap with a band gap of 2 electron volts results in all energies but the red being absorbed, leading to a red color. Red light has a frequency of 430 terahertz, while blue light frequency is closer to about 750 terahertz. Blue light also has shorter wavelengths with wavelengths between 450 and 495 nanometers, while red light has longer wavelengths with wavelengths around 620 to 750 nanometers.
After talking about frequency and wavelengths of blue and red photons, let's talk about incandescent light bulbs. Incandescent is just the fancy word for what your classic light bulb is. It works by the heating of the filament to a certain temperature that results in the generation of light. Incandescent light bulbs are not very energy efficient and unfortunately don't last very long compared to LED light bulbs. LED lights are made to last longer than the regular light bulb and are actually very energy efficient. Although the LED light bulb may look like your traditional light bulb, they are actually more powerful. Another big difference between the two is the price per efficiency. LED lights usually are way more efficient and cost way less than an incandescent light bulb when the efficiency level is very low. Also, an LED lasts longer than most relationships.